Hi guys, today we're going to talk about exponential functions. Okay, so you've studied the graphs of basic exponential functions. They're of the form f of x equals c times a to the x power. Now, if a is between 0 and 1, then a graph was exponential decay. Okay, so it looks something like this. Okay, and actually across more like this. Okay, and if a was greater than 1, it looks something like this. Okay, that's exponential growth. Exponential growth is what you want your bank account to do. Exponential growth is what makes millionaires millionaires. Okay, so let's look at a couple of these equations here. F of x equals 1/2 to the x power. Okay, so we're just going to graph this using a little table. Our friend is always the number 0, almost always the number 0. We plug that in, 1/2 to the 0 power is 1. Okay, so we'll graph 0, 1 right here. If we put 1 in there, 1/2 to the first power is 1/2. It's going to be like right here. And then 2 would be 1/4. So what this is going to do is this is going to get closer and closer and closer to the x-axis, but it's never quite going to get there. Now what if we go the other way? -1 would give me 1/2 to the -1 power would be 2. And -2 would give me 4. And -3 would give me 8. So this is what this graph would look like. This is definitely exponential decay. Things that experience exponential decay like this would be like radioactivity. Okay, things with a half-life, they actually follow this path right here if they're half-life. Okay. Now let's look at this one, 3 to the x power. So if we make a table with this one, again we plug in 0, 3 to the 0 power is 1. So it's going to go right here. I plug in 1, 3 to the first power is 3, 3 to the second power is 9, so it's going to go here, here. If I go the other direction, -1, that's going to be 1/3. -2 is going to be 1/9. So this is going to approach the x-axis this way. So it's going to look like this. This is exponential growth. Okay? Like I said, this is what you want your bank account to do. And the thing is with people's bank accounts is they become impatient because you're growing something and it grows really slowly for a long time until it reaches right here. And then it starts to explode in value. Okay? And people always get impatient with their investments and they start ditching them while they're in here instead of waiting until they get this part. Okay? And they start growing very rapidly. Okay. So, sketch the graph of each function. Okay, f of x is 1/2 x plus 2, 1/2 to the x power plus 2. This is going to be exponential decay. It's going to look just like the last one did, except that we're adding on to the end of the function here. So that's going to move the function up. Okay, so it's going to look just like this graph right here, except it's going to be moved up 2. So instead of crossing at 0, 1, probably best if you made the table. If I plug in 0, remember this is still 1 plus 2 is 3. So it's going to cross at 0, 3. Again, if I plug in 1, that's going to be 1/2 plus 2 is going to be 2 1/2. Okay. Okay, so that's going to be like right here. And it's going to keep approaching, instead of the x-axis, it's going to approach 2. It's going to go like this. It's never going to get to 2, though. Okay, it's going to get as close as I want, though. Now, if I plug in -1, this becomes 2 plus 2 is 4. 4 right here. And if I plug in -2, this becomes 4 plus 2 is 6. 6 right here. This is going to take off this direction. Okay? So there's my exponential growth. Like I said, it looks exactly like this one, except it's moved up 2. If you do it by transformations, this is the same part, but we just take all the answers and add 2. Now this is the same as the other one. It's exponential growth again, except that it's moved down 2 this time because we've got a 2 outside the function here. So instead of crossing at 0, 1, it's going to cross at 0, -1. And then we're going to go from there. Okay, so if I plug in 1, I get 3 minus 2 is 1. And, did I do that right? Yep. Okay, if I do 2, that'd be 9 minus 2 is 7. 1, 2, 3, 4, 5, 6, 7. Okay. And if I go the other direction, this is going to approach -2 right here. So I can actually kind of cheat on this thing and just kind of go like this. There we go. There's my exponential growth. Okay, let's let you do these two real quick. So go ahead and pause the video. G of x is -1/2 x plus 4. And h of x is -2 to the x minus 2 plus 2. So watch out, there's some negative signs on these. Give them a try and see what happens, and then jump back on and see how you did. Okay, so again, let's just go ahead and make a table. If I plug in 0 here, I get 1, but this is -1, so that ends up being 3. 0, 3. Okay, if I plug in 1, I'm going to get 1/2, -1/2, plus 4 is 3.5, 3.5. Right here. If I plug in 2, I get 1/4, -1/4 plus 3 is going to be 3.75. Okay, so this is a little bit different. You can see that this is always going to be a small number plus a small negative number plus 4. So this is going to approach the number 4. It's never quite going to get there. So let's go the other direction and see what happens. If I plug in -1, this becomes 2, but that makes it -2 plus 4 is 2. So -1, 2 is right here. If I plug in -2, this becomes 4. -4 plus 4 is 0. And we'll go one more, -3. So this would be 8. -8 plus 4 is -4. 1, 2, 3, 4. So what happened to this thing? Well, if I use transformations, it looks just like those other ones here, except it got moved up 4, and then it got flipped over. Okay. What did I do to my graph? I did my graph wrong, didn't I? Let's see. I plug in 0, that's 4. Oh, I got 0, 3. Okay, so I moved this. Let's correct this. Oh no, that was right the whole time. Okay, there we go. I thought I made a mistake, but apparently I was wrong. Okay, let's look at this next one. At this point, probably easiest to do it by a table. Okay, so now notice that this is inside the function now. This is not outside the function like this is. Okay, this is going to make a shift to the right or the left, and since it's subtraction, it's going to move it to the right. Addition would move it to the left. Okay, so this is going to look just like it's going to look just like this. F of x equals 2 to the x, except it's going to be moved up 2, it's going to be moved to the right 2, and it's going to be flipped upside down. Okay, so let's plug some numbers in here. 0 would give me 2 to the negative 2 would be 1/4. Negative 1/4, so it's going to be 1.75. It's going to be right about here. Okay, 1 would give me 2 to the negative 1 power, which would be 1/2. Negative 1/2 plus 2 is going to be 1.5. So that's going to be like right here. 2 oh, sorry, I put in, that was 1, not 1.5, or negative 1. 1.5 is going to be right here, sorry. Plug in 2, that's going to be 2 to the 0, which is going to be 1, but it's going to be negative 1 plus 2 is 1. So we go here. And then 3 would give me 2 to the first power is 2, but it's negative 2, so that's going to be 0. Four would give me 2 to the second power, which is 4, but negative 4, that's going to be negative 2. And you can see this thing's going to drop off a cliff here. Like that. It's going to approach 2 right there, but it's never quite going to get there. Okay, so hopefully you got those. All right, how do you use a calculator to evaluate a power like this? The powers, irrational powers. So, you probably already know how to do this. We're just going to go ahead and use our power key. So we're going to push 3, and then we're going to push the little caret button right here. So 3 to the, whoops. And then we're going to go ahead and push the square root key. So second square root. And we're going to go ahead and put a 2 in there. Now the newer ones, the older ones, they open up a parenthesis, so it looks like this. Push your second key, and then you push square root, and then it opens up a parenthesis like this, and you put in 2, and then you close the parenthesis. Okay, the newer ones, you don't have to do the parentheses. And you just hit enter, and this is approximately 4.7288. And it's set to 3 decimal places, so this would actually be 4.729. Okay, 3 to the negative pi. So it's going to be 3 to the, I'm going to use the negative sign. Remember, that's the one down here at the very bottom. It's not the minus sign, it's the negative. So 3 to the negative, and then the pi key. I hit second and the power key, and that's my pi. And then when I hit enter, that's going to be approximately 0.032. Okay, so make sure you check that you can do those on your calculator. Suppose you purchase a new car for $25,000 in 2020. The value of the car decreases at a rate of 16% each year to 84% of its previous value. What will the car be worth in 2024? How about 2028? Okay, so here's what we're going to do. We're going to use this equation. Okay, y equals c times a to the x. So c is going to be the original value of the car. In this case, it's 25,000. And a is going to be the value that it retains. So that's going to be 0.84. And then x is going to be the number of years. So 2020 is year 0. 2024 would be year 4. So we're going to go ahead and calculate this. 25,000 times 0.84 to the 4th power. And that $25,000 car is now worth about $12,446.78. Now obviously it's not going to be that accurate, but if you guessed around 12,500, you're in the ballpark. Okay, now I'll let you pause the video and calculate 2028, and then jump back on here and check your answer. Okay, so 2028 is going to be y is going to be 25,000 times 0.84 to the 8th power this time. Okay, so times 0.84 to the 8th power. That's going to be about $6,196.90. Okay, so if you estimated $6,200 or so, you'd be about right. Okay, this is why a car is never a good investment unless you get an antique car of some kind, which start appreciating in value. But 99% of cars depreciate in value, and so they're losing value all the time. If you did this with your bank account, if you said, hey, I'm going to give you $25,000 in 8 years, you're going to give me back $6,200, I'm going to think that's a pretty good deal, but you're not. Okay, here's your assignment. Hope you enjoy that. I will talk to you guys later. Have a great day.